Hello everyone. So today we are going to be looking at implicit differentiation. So the equation given to us is 2 raised to the power x plus 2 raised to the power y equals to 2 raised to the power x plus y. So obviously we can see that these are all exponential functions, and when we are asked to look for the derivative of exponential function implicitly, the first thing we need to do is try to compute the differentiation independently. Now, what I mean by that is we compute each term, we deal with each term as an individual entity, and at the end, we either add or subtract based on the operations between the functions. So, now, given this equation, let's consider just the simplest case. Let's assume that we want to look at the simplest case of a function y equals to 2 raised to the power x. If we're able to understand how to look for the first derivative of this simple function, then the same principle will be applied to the other functions individually, and at the end we look for our first derivative, right? So generally, for a simple function like this, to look for the derivative, we simply take the natural logarithms on both sides. So this implies that we are going to have ln of y equals to ln of 2 raised to the power x. We'll go ahead to simplify this, and simplifying this, we have ln of y equals to x ln of 2. Now, once we have this, we know that the derivative of a natural log function is simply the derivative of the function divided by the original function. The derivative of y is 1 divided by the original function y is y. Now, since we are differentiating with respect to x, we're going to have our dy dx function here. Now, this will be equal to, here we notice that we have basically a product function, right? This is one of the function and this is the second function. So we're simply going to apply our product rule in this case. So we'll consider one part of the function x, we differentiate the other, plus we consider the other and we differentiate the first one. So if we consider x, right, applying the product rule, the derivative of ln 2 is 0 because ln 2 is a constant. Now plus we consider ln of 2. Now the derivative of x is 1. Now, having this in mind, or having done this correctly, we have to further simplify our results. So dy on dx, we multiply all through by y. So we're going to have, here is obviously going to give us 0. So we have y the ln of 2. Now all that multiply by 1. There's a reason why I am putting the 1 here. So if we continue, we notice that our y from this, right, we know that y was 2 raised to the power x, right? So we simply replace that value. So our derivative will be equals to 2 raised to the power x, the ln of 2 multiplied by 1. Now, 2 raised to the power x is the original function we had. ln of 2 was the base of our function, and 1 was the derivative of the power. So having this general picture in mind, we can come up with like a formula. Let's say if we have a function f of x equals to the base, right? It can be any constant, or that raised to the power another function g of x, right? Then the derivative, oh my god, then the derivative of this function will simply be, we're going to multiply this function by itself, meaning that we're going to have the base, right, multiplied by raised to the power g of x, right? That is, this base is 2 here, and this power g of x is x here, right? Now this will be multiplied by the ln of the base, right? The ln of the base, and just the ln of the base now multiply by the derivative of the power. Alright, so once we have this picture in mind, we can solve any exponential function that is given to us. So we are going to use the same application to come up with the derivative of y equals to of this other function of this 2 equals to y, and also 2 equals to x plus y. So applying the what we've just learned from here, applying this above here, we're going to see that it becomes very easy. It becomes extremely easy because 2 raised to the power y, right? Our initial function 2 raised to the power y becomes 2 raised to the power y, right? We have multiplied with the function. Now multiply by the ln of the base. The base is 2, and the derivative of the power. The power is y, and the derivative of y is dy dx, because we are differentiating our function with respect to y. So multiply by dy on dx. It's that easy. So we don't need to go through all of these steps in order to come up with our solution or with our derivative. Once we have this formula in mind, it becomes very easy to solve. Now we're going to apply the same thing as well for this, and it becomes also very easy because we simply have to multiply the same function with itself, right? We have something like this, then multiply with the ln of the base. The base in this case also is 2, then the derivative of the power, and our power in this case is x plus y, and the derivative of x plus y implicitly is 1, right? The derivative of x with respect to x is 1, and derivative of y with respect to x is dy on dx. We see that it becomes extremely easy once we have that roadmap or the formula in our mind. So bringing this together, right? Bringing this nicely together, we're going to have the function to be, the first one, right, is 2 raised to the power x, the ln of 2 multiplied by 1, right, plus the second function is 2 raised to the power y, ln of 2 multiplied by dy on dx, and the last one, which was on the right hand side, was 2 raised to the power x plus y, the ln of 2 multiplied by 1 plus dy on dx. Okay, great. Now what we need to do here is simply expand our function, bring like terms together, and we make the dy dx subject of formula. So doing that real quick, we're going to have 2 raised to the power x ln of 2 plus okay, we also notice that ln of 2 is common throughout, so we're actually going to eliminate ln of 2 because it's a common factor. So simply eliminating or cancelling out ln of 2 everywhere, it simplifies our result, so it becomes easier to compute. So we're going to have here to be 2 raised to the power x plus 2 raised to the power y dy on dx equals to 2 raised to the power x plus y into 1 plus dy on dx. Then we're going to go further by expanding our function in order to bring the terms containing dy dx on one side and the other terms without dy dx on the other side. So we're going to have 2 raised to the power x plus 2 raised to the power y dy on dx equals to 2 raised to the power x plus y plus 2 raised to the power x plus y dy on dx. So as we said, we're going to send this way and this the other way. So we're going to have 2 raised to the power x, right, minus 2 raised to the power x plus y, and this will be equal to 2 raised to the power x plus y dy on dx, now plus 2 raised to the power y dy on dx, right? So we simply have good. So we simply have 2 raised to the power x minus 2 raised to the power x plus y equal to dy on dx into 2 raised to the power x plus y plus 2 raised to the power y. Now we're going to divide all through by this function. So finally we know that let me just change the color here real quick. Now finally we know that our dy on dx is simply 2 raised to the power x minus 2 raised to the power x plus y divided by 2 raised to the power x plus y plus, I don't know if it's plus. Now let's check this. So actually, if you check from above, I think this is really good so as to know if you're paying attention or not. Normally, once you send this function on the left hand side, it becomes negative. So actually there's supposed to be a negative there, and equally there's supposed to be a negative here as well. So great. Now if we have that in mind, right, good, if we have that in mind, then our solution becomes correct. So yeah, good. It's part of the learning process, making mistakes and learning from them. So I think that's the solution to this question. If you found this useful, if you learned one or two things from this, please kindly support me, kindly support my efforts. It takes an incredible amount of time to create these videos, given that I'm a student, and the best way you could support me now is simply subscribing and at least giving the video a like, and hopefully sharing it with others as well, so that the YouTube algorithm can recommend the videos to many more people and I can get more recognition for my efforts. So thank you again for watching, and see you in the next video.